And welcome back. We are going to go ahead and do a little bit of exception programming. Now, up to this point, of course, we have worked with some different pieces here. And one of the things that we've done here in this example program is that we're simply just getting a random number, and we are going to try to attempt to guess that random number. And you can see we have two private methods here. So there's one called user guess, which is simply going to go ahead and get input to guess a number between 1 and 100. And if it's not between it, we want to, of course, at that point, that will be where we throw our exception. And then, of course, we have a, hey, well, we want to check for this match here. So we want to check to see if it is. If it's not a match, we're going to have it re-guess. So notice I did start a catch here for a bad number because, of course, we want that number to be between 1 and 100. And, of course, creating that number exception is pretty easy. We would do this just like we would any other exception. We first create that class and have it extend exception. And then we would, of course, have a super invocation, just passes in the method. And then, of course, we have a one that would take a message, which is what we probably want it to do here. Because if you notice, we have a message that says now between 1 and 100. All right. So how do we want to get that actually to be in here? Well, we, of course, can just throw that new bad number exception. And if I simply just go ahead and throw it this way, you can see that's what we get. So let's just go ahead and just run this real quick and see, did we create this correctly or do we need to adjust our code a little bit? So if I just run this as is, and let's just go ahead and put a number that's, let's say, that is not between 100. Let's just put 0. We get not between 1 and 100. So we threw that exception, and notice the program stops. All right, so it just falls right out. And I didn't code anything either here for my exception, my general exception. So let's just go ahead and add in a print line here that just says not some thing that is known. All right, or we can even say some other error, however you want. Not some error that is known. How about that? A little more specific. It's not some error that is known. That way we, of course, can catch that general exception right there. And then we can, of course, look, okay, our program terminated when we had that. Well, why did it terminate? Because we look at it, when it catches this exception, right? So it finished this user guess program, and then it falls right out. So we don't have any way for it to come back out. Now, notice we do have it if we have it be able to recall here. So if we go ahead and rerun this program here, and let's just go ahead and put in a number that's between those two numbers. So let's say it's 45, and it says enter a number 100. So it called that user guess program again here, simply just because I went there. So let's go ahead and do 14 and 98. So we, of course, there are ways we can make this program better, right? We could, use like if-else statements to check to see if it's closer or farther away. But this is a quick way for us to start using these catch blocks to kind of start getting some input for us to look and say, hey, this is not between 1 and 100. Now, if we have, of course, our input mismatch here. So if I try putting in, let's say, the letter L, we get not a valid input. All right, so it's a very quick way for us to handle this exception here. And, of course, if we wanted to make this so that if we put in this program, because notice when it says not a valid input, we do terminate here. So we fall out of our program. We would have to have something happen within this method here that could have, of course, it happen in our main. Because if you look at our main program is actually very, very simple. We only have, effectively, we create the random, we create the secret integer value, and then, of course, we call the user guess method. So if we wanted this to loop, we would, of course, have to have some sort of loop mechanism. We could put that here inside of this program. And we could, of course, look to see if it is a valid number. So, we, of course, have this loop here because it throws this bad number exception if it is not valid. And then, of course, only if it gets out of this exception does it loop back around. So we could, of course, try to put this whole thing in a loop. So let's just go ahead and try. Let's just do like while true. And then I'm just going to move this curly bracket to the end here. And then let's just tab these guys over. So now you'll see it should keep looping. But we, of course, if we do that, we're going to call this method here, all right? So there's nothing for it to break out of this method. So if we go check for match secret, it could end up back in here. So, but let's just go ahead and just run this here. All right, so let's go ahead and just do an invalid number. So let's just do 0. All right, and notice this is not between 1 and 100. And notice it took us now back to the start of our program. Cool, so we are now back here. So let's go ahead and put in a valid number this time. Let's try 45. And notice it, even though 45 is a valid number, notice it did not break out of our program. So even though it's calling this method here, it doesn't actually break out. Now, if I put the break statement here before check for match secret, notice it gives me an error. It's like, hey, it's unreachable. So we want to have that break happen probably after the check for match secret. So let's just go ahead and rerun our code now. And if I put in 45 now, you see it's still looping. So we would have to, of course, play around with this a little bit to get this to be exactly the way we want this to go. Because it says check for match secret, but we are still technically inside this loop. So we would have to, this is where, for example, having a Boolean condition in here could be very helpful, because it could, even though this break statement is in here, it's a great way for us to update the flag list. But again, this is things that you can encounter when you start working with these exception statements, and you have to start figuring out, how can I make this program work the way that I want it to, so that way it's going to get all the exact performance of everything that I want. And I'm not going to go through and solve all those pieces today, but I just wanted you to see how we could very easily start putting those exceptions in here. Now, if I wanted to add other exceptions into this, obviously it's very easy to do. I could, of course, create other things in here. I could have other if statements or something like that. So, for example, if I had, right now I said if this guess is equal to num, do this, otherwise call the program. But what's if I wanted to check something else? I could easily have a else if in here and throw its own exception. Now, that would mean that this right here would have to be in its own try-catch block. But if you notice, we're only simply doing a comparison here, so there's nothing that we really have to worry about here in our program that's going to kind of really affect this. Now, I probably should update this one here to public, because this is, of course, being invoked here within the main class. But other than that, a lot of what we've been doing is really not that difficult once you kind of get the flow of how to work here with the exception statements and the exception handling. Again, if I wanted to try to use a try-catch here, I'm just going to quickly put one in here. I'm just going to do just a generic try-catch just to show you this. So if I go ahead and take, and let's just put this inside of a try-catch, and let's just encapsulate that. All right. Now, of course, it's saying, hey, we got some errors here. It's saying finally is expected. All right, we haven't put in here, of course, our catch block. So I'm just going to do a catch exception E. All right, just a quick generic one here. All right, and now notice, even though this is in here, I see why. There we go. There's our try block right there, causing issues. All right, and put one more in here. Boom, there we go. Now we got our curly brackets all situated. Got a little messy there. All right, now this one is fine because this is the general exception. But if I try to use, for example, let's just say I didn't try to use this try block here. Let's just say I try to take this try block out here just for a second. You'll notice that this catch block gives me an error, all right? And that's because in here, the issue is not that this is exception E is not a valid class, but the issue is that we are trying to say, hey, this try block, which exists someplace else, doesn't work. In fact, even if I were to, let me just delete these out of here, take this back to its original state. Even if I were just to put this try catch in such a way that it was only within this program here, like let's just say I try to do another try block here and just say try, and I'm just open and close, you'll notice it still gives me another error here, right? Because it's not knowing that these catch blocks are up here. So again, anytime we start a new try block, we're going to have to make sure that it has its own set of catch blocks. Even if it's the same exception class E, if I put that in here, now you can see it's happy. It doesn't have that error anymore. Because again, anytime we are coding with a try block, it has to have its own unique set of catch blocks. And creating those unique exceptions is really easy because again, all we need to do is create a no arg and then that string one. We of course can make ones with specific methods, but again, working with exceptions is pretty easy.